Okay, now let's look at question 7. In part A of the question, you are given two events A and B and two information, probability of A and probability of A union B. So you are asked to find probability of B if events A and B are mutually exclusive. So you need to recall the properties of mutually exclusive events. So if events A and B are mutually exclusive, then we know that probability of A intersect B is 0. So therefore, probability of A union B will be equals to probability of A plus probability of B. So the reason is because, as what I've just said, probability of A intersect B is equals to 0. So therefore, probability of A union B is equals to PA plus PB. All right. So now, what we are supposed to find is PB. So by making PB the subject of the equation, PB is equals to probability of A union B minus probability of A. So sub in the values and you can get the answer 0.4. All right, part 2. Now, with the same information, everything remains the same. You are asked to find PB again, but this time round you are told A and B are independent. So we know that if events A and B are independent, then it will satisfy three conditions. All right, so or three tests. So now we just make use of one of these three tests or one of these three conditions that event A and B would satisfy. So if they are independent. So since event A and B are independent, so probability of A intersect B will be equals to probability of A times probability of B, which is PA is 0.2 and probability of B is what we are asked to find. Okay, so now I just leave it as this for now and I call this equation 1. Okay, now we also know that based on the addition law of probability, probability of A union B is equals to PA plus PB minus probability of A intersect B. So by making PB the subject of this equation, so it is equals to probability of A union B minus PA plus probability of A intersect B. Okay, so now I can sub in the values and then for probability A intersect B, so from equation 1, I know that it is equals to 0.2 times probability of B. All right, so this is from equation 1. Now, with some manipulation, I get 0.8 times probability of B is equals to 0.4. So probability of B is just 0.4 divided by 0.8, which is half or 0.5. Okay, so that would be the answer for part A, part 2. Now, let's look at part B. In part B, the insurance company classify their car policy holder as three different kinds of risk, whether good risk, average risk, or bad risk. All right, and for each kind of risk, each type of risk, there's a certain probability whether the car owner will be involved in at least one accident or not involved. All right, so now part 1. you are asked to find the probability that a car policyholder was involved in at least one accident in that year, that same year, 2008. So therefore, in this case, we can work out the required probability will be, so for the car owner to be involved in at least one accident, the car owner can come from any of the three types of risk. So therefore, it can be from the good risk, which is 0.1, and then probability that a good risk car policyholder will be involved in at least one accident is 1%, which means probability of 0.01. And then probability that it is classified as average risk is 0.6, and probability for average risk car owner to be involved in at least one accident would be 0.15. So likewise, probability that is classified as a bad risk would be 0.3. And for a bad risk car policy holder to be involved in at least one accident, it will be 0.25. All right, so you need to consider all the three cases. Okay, whether classified as good risk, average risk, or bad risk, and their respective probability of that a car owner will be involved in at least one car accident to work out the probability for part 1. Okay, so part 2 is a conditional probability question. What's the probability that the car policyholder will be classified as good risk if, okay, in this case, if has the same meaning as given that. That means it's conditional probability. Probability that it is classified as good risk given that the car policyholder was not involved in any accident. So, given that no accident, all right, for that year. So, we are asked to find probability that is good risk, classified as good risk given that there is no accident for that year. So, we can rewrite it as the formula for conditional probability, which is probability of good risk and no accident divided by probability no accident. Okay, so probability that the car owner is classified as good risk would be 0.1. Probability for good risk car owner to have no accident would be 1 minus the probability that he will be involved in a car accident. Okay, so 1 minus 0.01. Probability no accident will be 1 minus probability that a car owner is involved in at least one car accident for that year. So it's 1 minus the probability that a car owner involved in at least one accident for that year is actually 0.166, which is the answer from part 1, B part 1. Okay, so press your GC or calculator and you can get the answer.